Please let me introduce Dr. Marie Moe, Unpatchable, living with a vulnerable implanted device.
Thank you. You hear me okay back there? Yeah? So I'm very, very happy to be here today at OS Gothenburg Day to give you a very personal presentation. It's about how it is to live with a vulnerable implanted device, a pacemaker that generates each and every heartbeat. It's not going to be a very technical presentation, so it's going to be a little bit different than the other presentations you had today. But I hope that by making this personal, I can be an inspiration and inspire you to do some more research. So I'm a security researcher. I am a hacker because I like to know how things work. I used to work with securing the national infrastructure in Norway. I ran a team of incident handlers doing 24/7 incident response in Norway. Today, I work as a security researcher at SINTEF, which is the largest independent research organization in Scandinavia. And I'm also a patient. Some doctors or medical device vendors might call me a difficult patient because I'm here asking difficult questions. I have an agenda with this talk. I want to inspire you to do some research, as I said, and I'm also doing some research on this. And I'm angry because I know how it feels like to have your body controlled by a machine that is not working correctly. I'm going to tell you a story about that in a moment. But first, the ones who aren't here, they can't tell their story. Think about that. So this is my story and my motivation. 4 years ago, I found myself lying on the floor without remembering how I got there. I didn't know at the time that it was my heart that had taken a pause. I went to the ER to get a checkup, and it turned out that it was actually my heart that had stopped beating for a while. 8 to 10 seconds is enough to leave you unconscious. My heart started beating again by itself, but with a very low and irregular pulse. But fortunately, there was a simple solution to that problem. I got a medical device implanted in my chest, a pacemaker, a machine inside my body that has software, hardware running on it. That is keeping me alive, so I'm really trusting this machine with my life. So since I'm a security professional, I'm of course interested in the security and the privacy aspects of having such a device. And I started to do some research on my own to figure out how my device worked. So I Googled a bit, I looked around, I read articles and found some patents and so on. And I found the technical manual of my device. And when I read it, I was a bit surprised because it turned out that my device has 2 wireless interfaces. I did only know about one of them. That's the very close range interface that is used when I go to checkups at the doctor's office, where he has a programmer that he has to take a reader and keep it really close to my skin to be able to communicate with the pacemaker. But there was a second wireless interface. There was a home monitoring interface in my pacemaker. It means that it's possible to retrieve logs from my pacemaker at a greater distance. If you have an access point, it can communicate over several meters with the pacemaker. And this access point will then, again, communicate over the internet and send my patient information to a server. And there's a web interface that the doctor can log into and get my information from. So this was something that was new to me. And of course, this close monitoring feature is very beneficial for a lot of patients. But with connectivity comes vulnerability. And for me, this is just an increased attack surface when I think about it. I'm not the only patient talking about these things. There are other examples like me. Maybe you heard about Karen Sandler. She's given some keynote talks and at different conferences. She's very passionate about free open software. And she's also dependent on a pacemaker, an implanted device. And she's really worked hard to try to get the software of her device. And she couldn't get access to the software. And also, there's another patient, Jay Radcliffe. He has hacked his own insulin pump and given talks about that. So maybe there's also someone in this audience that is depending on medical devices or has a close family member or friend that is depending on a medical device. You don't have to raise your hand to admit it. But if you want to, I'll be here after the talk. I'll be here a couple of hours hanging out, so you can come and talk to me. And if you have like a personal story that you want me to share, because I'm doing more talks like this, you can just share your story with me. I would be really happy to hear about it. And I could anonymize it and then bring your story forward if you want to. Okay, so let's make this personal. This is the stairs that almost killed me. I don't know if you recognize these stairs, but they are from a very, very long staircase at London Underground, the Covent Garden station. There's even a warning sign there. Maybe you can't read it. It says, stairs only to be used in emergency, and particularly not if you have a cardiac or heart condition. Obviously, I didn't read this sign, or I disregarded this sign. I was in London 4 years ago. This was just a couple of weeks after I got my implant. It was a very easy procedure. I was back at work again after 2 weeks, and I went to this SANS course in London on ethical hacking. And I was there with my colleagues, and we went off the underground at the station, and there were long queues to the elevators, so they just started to walk the stairs, and I just followed them. And when I came to like halfway up the stairs, that was the first time I figured that there's something wrong with my pacemaker. Because everything had worked perfectly fine until that moment. Of course, since I recently had the surgery, I hadn't done any training or exercise or something that would really beat up my pulse until I came to this really long stairs. And it was like, I really felt like I was going to die. Because I came like halfway up the stairs, and then I didn't have any more breath. It was like hitting a wall. It's like if you're running a marathon and you just come to a point where you can't make it any longer. It's just impossible to keep on going. But I still had to, because, you know, I could turn back and go down again or go up. It was like I was halfway through the stairs, so I just had to try to keep on going. And it was really, really painful and hard to finish those stairs. But when I came up again at the top, I made it. I survived. I didn't die. I was starting to feel okay again. So what I didn't know at the time was what actually technically had happened. I would only find out that later. So there was a mechanism, there was a setting, configuration setting in my pacemaker that was set to an upper heart rate limit of 160 beats per minute. And for a young person, that's quite low pulse if you're exercising or if you're walking up these really long stairs. So I had hit that maximum limit. And what happened then was that the pacemaker decided that I was having some kind of seizure or something, and it cut my pulse in half. So I went in a flash from 160 beats per minute to 80 beats per minute. And that really did not feel good. So it felt horrible. Yeah. Okay. I'm going to give you a small biology lessons here to give you the context here. But I'm not a doctor, so that's why I have this nice video for you about how the heart works.
A normal heartbeat rate and rhythm is called normal sinus rhythm. The heart's pumping action is driven by electrical stimulation within the heart muscle. The heart's electrical system allows it to beat in an organized, synchronized pattern. Every normal heartbeat has 4 steps. Step 1. As blood flows into the heart, an electrical impulse from an upper area of the right atrium, also known as the sinus node, causes the atria to contract. When the atria contract, they squeeze the blood into the ventricles. Step 3. There is a very short pause, only about a fraction of a second. And step 4. The ventricles contract, pumping the blood to the body. A heart normally beats between 60 to 100 times per minute. Electrical signals in your heart can become blocked or irregular, causing a disruption in your heart's normal rhythm. When the heart's rhythm is too fast, too slow, or out of order, an arrhythmia, also called a rhythm disorder, occurs. When your heart beats out of rhythm, it may not deliver enough blood to your body. Rhythm disorders can be caused by a number of factors, including disease, heredity, medications, or other factors.
So this is how the heart looks. So in my case, I have a condition that causes the electrical signals to be blocked on the way from the sinus node down to the ventricles. So it's called the AV block because it's something is blocking the pulse or the signal around the AV node. Fortunately, when this happened to me, my heart could beat even though I had this blocking. Because there are some other cells in the heart that can take over the pacemaker functionality of the heart and create a pulse. But this pulse is not very well regulated, so it will not give you enough oxygen all the time. It will maybe give you a pulse around 30-40 beats per minute. So when I was in hospital being monitored, my heart rate was around 40 beats per minute before I got the pacemaker. But if my pacemaker stops working, I hope that I still have this backup pulse. It's not for sure that I will have that, but most likely I will survive for a bit until I can get to the hospital and get a new pacemaker or get things fixed. At least I hope so, but nothing's sure. So this is my little friend, my pacemaker. It's about 45 centimeters big, and it's directly under my skin. And usually I don't notice it at all. So here you can see a small clip about how a pacemaker works.
A pacemaker is a miniaturized computer that is used to treat a slow heartbeat. It is about the size of a couple of stacked silver dollars and weighs approximately 17 to 25 grams. It is usually surgically placed or implanted just under the skin in the chest area. The device sends a tiny electrical pulse down a thin coated wire called a lead into your heart. This stimulates the heart to beat. These impulses are very tiny, and most people do not feel them. While the device helps your heart maintain its rhythm, it also stores information about your heart that can be retrieved by your doctor to program the device.
So did you notice those ones and zeros flashing over the pacemaker at the end of that video? Those are the bits that I'm going to talk about today and that I'm a little bit concerned about. But first I want to show you how pacemakers are constantly evolving. And they are getting tinier, smaller. This is a version that actually is on the market today in Europe. It's a pacemaker that can be implanted directly into the heart, so you don't need to have the wires, the leads. And I think that in the future, these devices will become really small and they will be even better integrated into our bodies. I think that in the future, a lot of you people also in the room will live much longer and have better lives due to medical implants like pacemakers and other implants, because the technology is amazing and it can keep us alive for longer. This is a very fascinating, more experimental prototype of something called a cardiac sock. So I have to show you this clip. This is showing how, this is a rabbit's heart. and it's living outside of the rabbit's body. So this is actually keeping the heart pumping, even though it's not connected to a body, it's not alive. So these are tiny, this is actually 3D printed as a piece of sensor equipment. And I think that this is actually something that will become more relevant for all of us, not only for a small group of pacemaker patients. Even though we are quite many people that get pacemakers, most of them are of higher age than me. In Norway, it's around 500 per 1 million inhabitants that get a pacemaker implant each year. So they implant around 2,600 pacemakers, new implants each year. Average age of a person receiving an implant is around 80 years old. So I'm a sort of exception from the normal pacemaker patient. So are we trusting machines? Anyone recognize this photo? It's from a very good film, I think, Ex Machina. It's a Swedish actress. And did you know it's actually, most part of that film is filmed in Norway? I really like it. I'm not going to spoil the film for those of you who haven't seen it. But I think it's really relevant that, so when I saw it, I was thinking about this, how we are gradually becoming more and more dependent on machines, and how we need to trust this technology. And I'm trusting this technology today. I'm trusting it with my life. I'm trusting this piece of software running in my heart. So should I do that? How can I trust it? And also, the Internet of Things is here. But we also have something called a medical Internet of Things. And my heart, as I mentioned, is possible to connect, or it can at least connect out via the Internet. It means that I'm sort of wired into this Internet of Things. And this is something that is coming more and more. So this is an illustration of how this remote monitoring works. So it's the pacemaker that can communicate via an access point or a home unit. It's via the cellular network or the internet or the telephone line over to a server, and then there's also this web interface that the physicians can log into. So when I look at this picture, I see a lot of potential threats, like attack scenarios. For instance, I mean, you can have something going wrong in all of these places. So the device itself could be vulnerable, or it could contain some software bugs or whatever that doesn't make it work like it should do. And we have this piece of electronic equipment here that can also have some vulnerabilities. And I'm really interested into looking for the crypto mechanism that is used to communicate out from the access point. Of course, also between my pacemaker and the access point. And all of these are proprietary systems. It's not open software. It's not so easy to get hold of. So in my hacking project, my small hacking project, I have a small team of researchers actually spending some of their free time helping me with this. I have gone on eBay and I purchased some of this equipment that can communicate with my pacemaker. And we just started to look at them, and I'm really excited to see where this will, what I will discover. And then there's also, of course, the possibility of having some insider threats in the network, compromising my patient privacy, my information. The server could be compromised, hacked. The web interface could have vulnerabilities, and so on. So there's a lot of things that can go wrong. And these are some things that might happen due to things going wrong in this system. As I mentioned, I'm concerned about my personal information. I actually would like to have access to my information on my device. I can't do that today. I can't get my data, my logs on my pacemaker. Also, I don't want this information to get in the wrong hands. If you create some kind of custom device talking a lot to my pacemaker, it can deplete the battery. And that's really bad because the battery lasts around 10 years. That means that I need to have a new surgery in 6 years' time to replace it. You can actually create a kind of pacemaker exhaustion device that will make it last not that long. You can cause the device to malfunction, perhaps by exploiting its or man-in-the-middling the communication with it. And there has also been some press articles lately, I don't know if you noticed, about how ransomware can get into medical devices. It sounds really horrible that you can compromise someone's medical device or implant and then ask for money to not kill you. Sounds like a bad movie, I think. And there have been some movies about this, or if you've seen Homeland, there was an episode about how the vice president was assassinated via his pacemaker. So these are some things that you can start to worry about, of course. Not all of them are that likely, I think. Yeah.
Before Barnaby Jack died, there were speculations that Dick Cheney had a device that was actually one of those that he was rejected.
Yeah, so Dick Cheney did give an interview about how he had disabled the wireless interface on his pacemaker because he was afraid of getting hit by a targeted attack. Yeah. So if you're like a person of interest, this is maybe a real attack scenario. I don't worry too much about that. I worry much more about software bugs on my device, to be honest. But we need to be able to somehow verify this software that runs and controls our lives. And I really like this quote from Bruce Schneier, talking about referring to the Volkswagen cheating scandal. So the point about this quote is that it was a third party, it was a private lab that found this software issue in the Volkswagen cars. So it's not enough to let the regulators or the vendors themselves look at their or do code reviews and do their software lifecycle processes and so on. We need to have third-party testing, we need to have transparency. And we need to make it legal to analyze the code. And for that, I'm really happy that we have got the DMCA, Digital Copyright Millennium Act exemptions that will be valid in less than a year from now. So it will now be actually legal you will not violate any copyright infringement by doing research to see if medical devices and medical implants are secure. So it's actually will become legal to do security research on them, which I think is really good. And I hope that will inspire more researchers into the area, that we will see a lot more focus on medical implants. So as you mentioned Barnaby Jack's research, this is the first academic research that was done on the security of pacemakers. It's from 2008. So there's a group of researchers led by Kevin Fu in the US that did some groundbreaking research on pacemaker communications. And they showed that it's possible to hack the devices, at least the devices they were looking at that time. So they could quite easily reverse engineer parts of the communication protocols that were used between the pacemaker and the programmer, which is this device that the doctor uses at the checkups that has very near-field communication. And they were able to hijack this communication channel, and they were able to issue commands to the pacemaker to make it shut off, to make it deliver shocks There are some types of pacemakers, not the type that I have, that can actually give a shock to the heart in case the heart stops. And they could also retrieve personal data from the devices. They proved that it was transmitted in clear text, no crypto used to protect this information. So you could figure out the name of the patient, date of birth, the ID, the serial number of the device, the doctor's name, and a lot of other information that you could easily get from the pacemaker. But what was good about this, or good for me as a patient when I read this paper, is that you need to be really close to be able to carry out this attack, like centimeters away from the person. So that was like, if you compared that to like a threat scenario, someone would actually have to attack me with some kind of custom-made device that costs tens and thousands of dollars and to kill me. And I think there are easier ways to kill me than that. But then we have the research done by Barnaby Jack. He was going to present this 2 years ago at the Black Hat and DEF CON conference in Las Vegas. I was actually at that conference. I had really looked forward to this talk. I was planning to seek him out and talk to him about it, and I was really interested in his research, of course. But then sadly, he passed away. I think it was just a week before he was going to give his talk. And his research has not been taken up by any other researchers since then, as far as I know. So what he did, he extended the range that you could carry out these attacks, the same types of attacks as Kevin Fu and his group showed in 2008. So he showed that it's possible, or he made a kind of device that, or a computer program running on a laptop with just an external antenna. He could scan a room and get serial numbers off of the pacemakers in the room. So it's like going in a room and scanning for patients with pacemakers. And then he could also hijack the communication channel on a larger distance. I think it was up to 9 meters or something. So this is not a very good thing, but of course you need to be really dedicated and have this, you need to be in the same room as the patient, so maybe not so easy to get away with. At least you need to have some really good spy plot going on there to kill someone. What I'm worried about, of course, is this connection to the internet. Until today, as far as I know, no one has proved that it is possible to connect to pacemakers via the internet and disable them or do some or manipulate them somehow. But that's, of course, something you need to have in mind when you build these systems and this connecting all the devices to the internet. I want to refer to this. This is nothing to do with pacemakers, but it's medical devices, and it's about hacking drug infusion pumps. I'm sure a lot of you have seen this. It was from this summer or this year. So researchers proved that it was possible to actually, if you were on the hospital network, you could access all these medicine drug infusion pumps that are typically used to deliver medications via IV to patients. So, for instance, morphine. And it was possible to tamper with the settings so that you could deliver fatal doses of drugs. So this is really bad thing. And there was a lot of problems with the coordinated disclosure process on this one, where the vendor claimed that, no, this is nothing to worry about, and then the researcher had to go back and make a new proof of concept and show that, yes, actually, it is working. You can do this. And what the vendor claimed first was that, no, this is not possible, because the communication module is separated from the module that decides the dosage of medicine. There are different circuit boards and everything. But if you look here, so there's a serial connection between them, of course. And this if you look into the details of Charlie Miller and Chris Walczak's work about hacking cars, you can see that it's the same thing there. You can actually jump from the communication part over to the internals. But this, of course, requires some hard work and a lot of research. But what's special about this case is that the FDA, they have started to focus more on cybersecurity. FDA is the US Food and Drug Administration, and they are the regulator that can allow medical devices onto the US market, so they have a lot of power. And they have started to be much more concerned about cybersecurity issues and hacking. And this is the first example of a medical device being recalled by the FDA because of because of a cybersecurity issue. So this is as close as you get to a recall. They are really, they call it a security communication. But they are actually saying that you should not use these brands of infusion pumps because they are dangerous for patients. Another thing that's also great with this example is that usually they don't recall drugs or equipment before they have proof that a lot of patients have died because of this issue. So this was like a proactive recall where researchers just show that it's possible to kill patients. No one has been killed yet. I like that kind of research where you don't have to actually kill someone. It's a good thing. So they did this proactively, and they recalled it because of the threat of killing patients, not actually patients being killed. But as I said, these are like quite specialized type of attacks or proofs of concepts that require a lot of research. But you also have all the normal viruses and threats out there, like Trojans and things. And also, these are a little bit more, let's say, low-hanging fruits for researchers to look at. But a lot of research has been done into showing that hospital networks are really not that secure, and they can get infected by all types of malware, like normal malware. So in this report by TrapX, they have gone into several hospitals and looked at their networks and looked for infected devices on the networks, and they found something, I think, almost everywhere. So you have all these embedded devices running on, let's say, Windows XP embedded and so on. They're not always very well patched, and they're not always very well. The networks are sometimes not very well segregated, and so on. So you have in this paper examples of blood gas analyzers, X-ray machines, MR machines with malware on them, which is really concerning, I think, because you really want this type of equipment to work as it should. And how can you guarantee that this equipment is working as it should if it's running SUS or whatever type of normal Trojan malware? TrapX found SUS and Citadel on these devices. Doesn't seem really targeted, but anyway, it can cause some problems if they're starting suddenly to do a lot more networking or something. And this example, there is something called a PAC system. This is a patient record archive system, which is connected to the CT scanner, the X-ray machine, and so on, because this is the place where all the images are being stored. And they actually found out that there was a Trojan, this was compromised and sending information out to China, which is not really a good thing if you think about your patient privacy. So, and also, these things are on the internet, and they have bad or hard-coded passwords or bad default passwords. This is another example of research done by Scott Irwin and Mark Kalau. They presented this at DEF CON this year. So they were focused on, they actually used Shodan to scan for GE healthcare equipment, and they found a lot of equipment available online and not really well protected. So these are the passwords that were on these devices, And you could easily find those passwords by just looking in the documentation or the manuals. And the vendor claimed that, no, this is not hard-coded. It's just default password. You need to change them. But then when the manual tells the operators not change the password, because the vendor needs to have remote access to update or upgrade it, then you have a problem. So, yeah. I'm not going to comment on these passwords any more than that, I think. Also, you can have malicious software updates, like waterhole attacks, where this is an example where a ventilator manufacturer had some kind of problem with a website, and their software updates were Trojanized. So if you log into this as a hospital technician, you want to update your medical device, you get some malware at the same time. Not really a good thing. And also, I want to show you this example. It's about how can we actually we are really depending on these types of medical devices, medical implants, and someone is in this Amazon Web Services forum. It's a quite old thread. It's posted in April 2011. So there's a person working for a monitoring company that monitors hundreds of cardiac patients at home, and he cannot see their signals because the cloud service provider is down. So that's a problem. So some solutions to this. First, why do you put critical patient safety systems in the cloud? Maybe you should have a better redundancy on your systems. I think this might be like a smaller startup company or something, because they don't really seem to have their contingency plans in order. Maybe you should pay a little bit more and get better SLAs. At least they need to have some kind of backup plan when this happens. So why are we in this situation, just to sum up? We have a lot of legacy technology. We have a lot of medical devices that are not being replaced that often. So like my pacemaker, every 10 years. And you have, of course, other types of medical devices that last much longer than that too. And some of them don't get any software updates. And then you have a lack of security testing or also security monitoring. The hospitals don't know what's going on their networks because they don't look. They don't look for infected devices. And these medical devices are black boxes. We can't really look into them. There's no transparency. We don't know how they work. We have to buy them on eBay and hack them to figure out how they work. It's not really a good solution. And there's proprietary software. And everything is getting more and more connected. And there's a lack of regulations in this field. And there's increased attack surface because of that. How to solve it? I don't want to just stand here and talk about what's wrong. I want to give you some hopes for the future. So we need to have more security research. That's like my main argument here. We need to do information sharing, and we need to do third-party collaboration and coordinated disclosure. I wouldn't like to have full disclosure on this if someone finds a really critical bug or vulnerability in my pacemaker, because that would not feel good. I would like to work with the vendor and make them find a patch and a way of patching it. And the vendor needs more awareness. Maybe they need to be forced a little bit. We need more regulation. In the procurement phase, you can also do something. You can educate the persons that purchase this type of equipment and tell them to ask questions to the vendors, to ask for their security solutions and how they have been testing their security. And then, of course, we need to have safety by design. We need to have secure coding, as you all know. That's really important that we don't add on security afterwards. We need to have it there from the start. So we have a long way to go. And then we also need to do some security risk monitoring. We need to have ways of patching, security updates, and incident response. So we need to be prepared for more vulnerabilities being found in these devices. Maybe cyber insurance could be one part of the solution. So if it's really expensive for the hospitals to get their insurance because the risk of leaking patient information is very high, maybe they need to do something about their systems. So we need to add resilience into the systems. And I want you to start hacking. Hack to save lives. I want you to be interested in looking at medical implants and medical devices. So I'm part of a group called I'm the Cavalry. So if you're interested in contributing, you can look at our website, imthecavalry.org. We have a discussion forum. We also have people that are contributing, and we are on a Slack channel, sharing a lot of information. And I got a lot of good contacts via that network. So please come to and talk to me about I'm the Cavalry if you're interested. It's not only medical devices that is part of what I'm the Cavalry is working with. So I'm the Cavalry is just it's a non-profit. It's actually only volunteers volunteering part of their time, contributing with what they can, and I'm contributing on the awareness raising in this context. So we want to improve visibility and awareness of these issues while working also with the other stakeholders to preserve trust and find a way forward in solving this. So it's also with the automotive industry and with the smart home connected Internet of Things that we are concerned about. But of course, there will be bugs, as Joshua Corman of I Am the Cavalry said. And I want to go back to the story I started with, the story about climbing the stairs. So I had to figure out what was wrong with me when I had this moment of feeling like I was going to die. So I needed to be debugged. And how do you debug me? This is a picture of how it looks. This is not me, but another patient. But it's describes it very accurately. So the patient is lying here, and you're being hooked up to one of these. You see there's a stack of programmers there, because each brand has their own programmer. So the first thing when you come into the hospital is, okay, I carry an ID card that says what type of model I have and what type of brand of pacemaker I have. There are like 4, 5, 6 vendors of them. But if I'm unconscious or they can't find my ID card, they need to figure out what type of pacemaker I have. And they need to find the correct machine that can talk to my pacemaker. And then they can start interrogating it and looking at the settings and the logs and so on. So this is where the debugging is being done. So I had to go back and forth, I think for 3 months before we figured out what was wrong with my settings, because there was a problem. In the end, I had to do a test where I was on a bicycle and exercising and being monitored very closely to see what was going wrong. Because there was some kind of problem with the user interface here that the pacemaker technician looked at. It didn't really display the same settings as my pacemaker had. So I think it was some kind of bug. I've been reading it through my patient records to figure out what was really happening. And one of them has a remark about maybe we need to call the vendor about this thing. So yeah. So these programmers can be patched. You can get the software update, put it on a USB stick, and then patch it, and then it can again communicate with the pacemaker, and in case it needs to be patched. There's a lot of issues around this patching procedure, I think. Okay, so this was like a lucky ending of my story. We found out what was wrong, we got the right settings, and now I can do whatever I want. I can live my life normally. This is the research that I feel is needed, that I want you, like the next 5 or 10 years, I would like to see some progress, some research on this. So these are some suggestions of things that you can start to look at. I think it's really interesting to have open source medical devices. I know there are some groups that are looking at this. Medical device cryptography. We need to have some cryptography that can run on these small embedded devices that really works. And there's all this issue with code signing and things not being online and so on that we should look into. Maybe we need to have some kind of personal area network monitoring. At least I would like to have that. Also, jamming protection. It's not a good thing if you can jam these devices. I know they are built to resist jamming, but anyway, it's possible with a large enough effect to jam it. And if something wrong happens, if I just suddenly drop dead, how do you know it's something with my pacemaker or something with my heart or whatever happened? You need to have some way of having forensics captures, evidence capture on these devices. And I need specialists on pacemaker forensics. I don't think they exist. But I want to say that the benefit of having the device, it really, for me, that really outweighs the risks. So before I finish, I would like to say that as a pacemaker patient, I'm really happy that we have this amazing technology. And I'm glad that the FDA has begun to look at cybersecurity issues of medical implants and the medical Internet of Things. I think that's really good. And I wouldn't want life-saving devices to not come to the market because it's taking forever to get them through the security evaluation either. And I don't want to discourage any patients from getting a life-saving device because they worry about the cybersecurity or because of technology fear. So for me, having the device means that I can live my life just like I want to. The only thing that's a little bit inconvenient is when I travel and I have to go to the security control, the checkup, because I have to go outside of the metal detector and always have the manual pat-down. It's a little bit inconvenient, of course. But except from this minor annoyance, my life is just as before. Without the pacemaker, I wouldn't be able to travel here to Gothenburg to give you this presentation. Without the pacemaker, I would have a very low pulse and a low quality of life. I would not be able to work out, not be able to even work, I think, because of the fatigue of having such a low pulse. And without the pacemaker, I would be in constant risk of passing out suddenly and not waking up again. Without the pacemaker, I would be in high risk of sudden cardiac death. And I would probably not be here today. So just to brag a little bit, I finished half marathon, Oslo Marathon this year. So this is me running with a pacemaker. And I want to, oh, what happened with this slide? I'm sorry, I messed up the formattation of this slide. But I have a lot of people that I want to thank that have helped me a lot with and encouraged me a lot to do this talk and do my research. So thank you.
Thank you very much. It was very inspiring to me, at least.
Thanks.
Questions?
As I said, I will be here, so if you want to talk to me later, I'll be there. There's one question over there. Yeah.
Thank you. So if you have all these different kinds of programmers, it might be interesting to look at some kind of standardization for having these devices.
That would be really interesting to look into as well. Yeah. And not to have all these different proprietary systems for communicating with the pacemakers. Yeah. And also look at the HMI that the technicians or the doctors use so that they don't mess up and do something wrong with the settings. Mm-hmm. Because they have to learn all these different interfaces as well.
I am the Cavalry, you said that is non-profit, right?
Yeah, it's a group of volunteers. It's not really a non-profit organization
now,
yet.
Yeah, what I meant is like, why hackers like us should help for free big corporations to spot bugs without getting paid?
Yeah, so
like why there are these kind of ideas of having like a group of people that work for free and just help these multi-billion-dollar corporations to like fix their products without even getting paid, you know, just for the sake of what glory.
I think we should get paid. I really support the idea of having bug bounties and paying researchers to do the work.
Good.
Yeah.
Thanks.
So I don't know if there are any other questions, but I do have a question, or rather your opinion on, you have very small resources on embedded devices, and how does that work with crypto, and what do you think are the limitations? And
yeah, I really would like to work more on looking into the crypto that they are using on these devices and see if it's possible to have some good solutions for these embedded devices with limited resources on processing. And it's very interesting how you can do software updates and patches also while having the device, because you don't want to disrupt its functionality. So you want it to still be giving a pulse to the patient. At least for me, since every single beat of my heart is generated by the pacemaker, it's really important that it doesn't stop working.
Yeah. All right, more questions? Yes, good.
I think you'll hear me fine. Could you tell us a little bit about the response you got when you raised your concerns to the vendors and the doctors?
So I haven't done any disclosure with the vendors yet, because we just started this project on looking into my particular devices. But I'm really looking forward to, and I think I will learn a lot from doing that. So I have got contacted by some vendors already that were curious about what I was going to talk about. Yeah. And I really like that people reach out to me and are interested in this. So that's also a way of doing research, is that when you do talks, you get more people interested in asking questions, and you get people contacting you and want to contribute, and I think that's really great. Yeah.
All right. Let's thank Marie again.